Hi, so today we are going to talk about stoichiometry and yield. This is the third worksheet in our series for moles, and this one is basically bringing all the concepts that we have studied together, especially adding on stoichiometry, concept of solutions, and yield into the mix. Alright, so let's get started. In the first question, we want to make calcium nitrate, and they're starting with pure calcium oxide. So let's try to write the ingredients. So we are using calcium oxide and an excess of dilute nitric acid. Now remember that if you have excess of that thing, that means you're not running out of it, which means you don't need to worry about its amount anymore. The thing you need to worry about the amount or track the amount of is the other thing, which is not in excess or which we call limiting reactant. So in this case, this is calcium oxide. We are going to produce calcium nitrate from it. So that's the equation. And obviously this will produce some water. And the only thing that matters for us is the mole ratio between the limiting reactant and the product we are concerned about. Everything else, even if you don't know how to make that equation at the moment, that's perfectly fine. Just know what the mole ratio would be. So this is going to be 1 to 1. And because we're talking about the masses, it's a good idea to figure out the MR of these compounds. So for calcium oxide, it's 40 for calcium and 16 for oxygen. So that's 56 grams of 1 mole. And similarly for this one, if I calculate it, this is nitrate. So nitrogen is 14, oxygen is 16. So 14 plus 3 times 16 for nitrate, multiply that by 2 plus 40 for calcium, and you have 164 grams for calcium nitrate for 1 mole. So that's the grammage for 1 mole MR. Alright, so basically this is creating a ratio there that 1 mole of calcium oxide produces calcium nitrate of 1 mole, which basically means 56 grams of calcium oxide produces 164 grams of calcium nitrate. So if that is the ratio, that 56 produces 164, how much would 8 gram produce? So 8 will produce X amount. So you cross multiply, you get 164 times 8 divided by 56. Now that is the value, which is 23.4. Now remember that this is basically a ratio method. But if you're somebody who prefers formulas, then that's perfectly fine. Just figure out how many moles is calcium oxide. So I'm going to do that on this side. So number of moles of calcium oxide is 8 over 56. And because it's a mole ratio, then that tells me that mole ratio is 1 to 1. So moles of calcium nitrate will also be 8 over 56. Now I'm going to take that and multiply it by MR to figure out moles of mass of calcium nitrate that will produce. So that's going to be moles multiplied by MR. MR is 164, which is again going to be 23.4. Now I need to know the yield. Yield is basically how much did I actually produce compared to how much I had to produce. Theoretical yield, which was 23.4, and practical yield, which was 12.65. So when I take the ratio of that and I multiply that by 100% to figure out the percentage yield, I get my answer to be 54%. Alright, which sample contains the most atoms? Again, the question is pretty straightforward. We need to figure out the atoms, but for that, let's try to write the formula. So H2O, CO2, CH4, and HCl. Now, how many atoms do they have in one molecule? This one has 3, this one has 3, this one has 5, and this one has 2. So I'm multiplying that to figure out how many moles of atoms I have. So 1 mole of water will have 3 moles, so half a mole will have 3 times 0.5, which is 1.5. This one's going to be 3, this one's going to be 2. In fact, this one is going to be 5, and this one's going to be 4. So judging by that, my answer is going to be C, because it's producing the most number of atoms. Which statement is correct? Let's read them. The concentration of a solution is expressed in dm cube per mole. In fact, it's the opposite. It's mole per dm cube. So this one's wrong. Empirical formula, remember, it's the formula that gives us the simplest ratio. But this one's saying it gives the actual number. In fact, that is what molecular formula does. A molecular formula for compound always contains more atoms than an empirical formula. Think of an example, a simple example that does not follow this. For example, H2O or NH3. They don't follow this. They have the same empirical formula, molecular formula. So this one's wrong. Clearly, last one is going to be our answer. which is relative atomic mass. Now remember the definition, that it is the average mass of all isotopes, in fact all natural isotopes of an atom, compared with 1/12 of carbon 12. Alright, let's do question number 4. The equation shows the production of iron by reduction of iron 3 oxide, Fe2O3, okay, 80 tons of iron 3 oxide, so that's 80 of this, produces 50 tons of iron. So that's one scenario in which they did. But what's the actual number? Let's see. Now MR of Fe2O3, I'll need to calculate that. That comes out to be 160. So 160 of this should produce 2 times 56, because that's the AR of iron. So that is 112. So the ratio I'm getting is 160 should produce 112. So how much should 80 produce? Now remember, I'm not using this 50 at the moment because this is my practical yield. I want to know what my theoretical yield is going to be, my value from stoichiometry. So 160 is producing 112, 80 should produce X, 80 if you do it, it will produce 56. So that means 80 tons will produce 56 tons. Now, what did I actually get? 50. So 50 over 56 times 100%. That's going to be 89%. And that's my final answer. Now, if you don't like ratio method, then again, you can use formulas. So according to the formula, number of moles of Fe2O3 is 80 over 160, which is going to be 1/2. Now, look at the mole ratio. One mole of Fe2O3 produces 2 moles of iron. So half should produce obviously 1, and judging by that, that is going to be number of moles is mass or MR. So 1 times 56, that is 56 grams that I should be getting. Of course, that's my theoretical value. 50 over 56 is going to give me the yield that I have. Ethanol can be made by the reaction shown. Okay, if 5 grams of C2H5Br bromoethane produces 1.59 grams of ethanol. So again, this one is going to be my practical yield, and I'm going to use that later on. So mole ratio is 1:1, which makes things much easier. Let's calculate the MR, which we already have. Now using that, I can see that 1 mole produces 1 mole of that. So 109 grams should produce 46 grams. Of course, over here I have 5. So how much should that produce? X. When I do that, I get X equals to 2.11 grams. My yield is going to be 1.59, which is what I actually got, divided by what I should get, 2.11 into 100%. Now again, if it's somebody who prefers formulas, then number of moles is going to be, you have 5 grams of ethyl bromide or bromoethane. So you're going to take 5, which is the mass, divided by the MR, and that's your moles of bromoethane. Judging by the mole ratio 1:1, that is also the moles of ethanol. Now, when I multiply moles with MR, which is 46, I get my theoretical mass that I should be getting, which is again 2.11 gram. Finding the yield through the same method gives me 75% as my percentage yield. Alright, now we are on page 2. This is question number 6. Let's see. A mixture of 5 cm cube of methane and 100 cm cube of air is exploded. Now, methane is flammable, oxygen is present in air, so they're going to react obviously. Assume air is 80% nitrogen by volume and 20% oxygen by volume. Okay, the resulting mixture is cooled. All volumes are made at room temperature and pressure. Why is that important? Because, for example, if steam was produced, now it is liquid. And that's an important thing to remember in a question like this. What's the composition of resulting gas? Now remember Avogadro's law. Avogadro's law says that number of moles of gases is comparable, or it's directly proportional to volume of gases, which means that I can take the number of moles and volume ratio to be comparable. Judging by that, if I have 1 mole of methane producing 1 mole of carbon dioxide by using 2 moles, I can say that if I had 5 cm cube of this, I will need 10 cm cube of this to produce 5 cm cube of this. Now remember, the mole ratio and volume ratio are basically the same. That's the law I'm using here, which means I need 10 cm cube of oxygen to completely react with this. I already have 20, so that's fine. I have 10 that I'm going to use and 10 that is left over. So that means in my second column over here, I should get a tick mark. Now 5 cm cube of CO2, of course, that's being produced. That's also correct. And in fact, that's in all the options. But my options are now A and B narrowed down. Nitrogen is not part of this reaction, so nitrogen is also going to be there. But I'm not going to get any steam anymore, because even if steam was produced, it has been cooled down to water. So my answer is going to be B because of this. So steam is not present, that's B. The reaction for conversion of bromoethane to ethanol. This is an equation that we just saw in question number 5. In an experiment, 10.9 grams of bromoethane is converted to 3.45 grams of ethanol. What is the percentage yield of ethanol? Again, very similar question. We have already done this in different values. So 109 gram produces 46 grams. So 10.9 should produce X. This is pretty straightforward. Notice that the decimal has moved just one step, so that's going to happen here as well. So I'm going to get X equal to 4.6 grams. Now, what did I actually get? 3.45. So that's going to be my percentage yield, my practical value over my theoretical value, which comes out to be 75%. 1 mole of sugar is burned. Which volume of oxygen is required for complete combustion? Now that's pretty straightforward. We'll simply make the equation CH2O, that's the empirical formula, multiply by 6 to give me the glucose, plus oxygen makes carbon dioxide and water. Now if you remember the equation for respiration, this is exactly what it is. Now that's going to be 6, 6 and 6. Now the ratio is 1 to 6 for oxygen and glucose. That's all I need to know. I don't need to know how much carbon dioxide is produced, how much water is produced, because these are the two things that matter at the moment. I'm burning 1 mole of this, so I'm going to use 6 moles of oxygen. What's the volume of 6 moles of oxygen? Remember, 1 mole of any gas takes 24 dm cubes, so this is going to be 6 times 24, which is 144. A sample of magnesium hydroxide is made by adding an excess of aqueous sodium hydroxide. Now again, because this is an excess, we don't need to worry about its amount, but we just need to know the mass of magnesium hydroxide that is produced. Alright, let's see. Now the mole ratio will again be 1 to 1 because magnesium sulfate is producing Mg that is being used here. So the mole ratio is in fact going to be 1 to 1. So let's figure out the MR. For magnesium sulfate, my MR is going to be 120. And for magnesium hydroxide, my MR is going to be 58. You can easily calculate it. Now, judging by that, because they're 1 to 1 mole, 120 should produce 58 and 1.2 should produce X. When I calculate that, I get 0.58 grams. Now, my percentage yield is going to be 0.26 divided by 0.58 times 100%, and that's going to be 44.8%. Now, again, if you prefer formulas, then number of moles of magnesium sulfate is going to be 1.2 over 120, and that's also going to be the number of moles of magnesium hydroxide because the mole ratio is 1 to 1. So that will give me 1.2 over 120, that's my moles, multiplied by MR, giving me mass, which comes out to be 0.58. Now judging by that, I'll use the same formula for yield, and that gives me 44.8. Alright, let's see. Question number 10. A mass of 63 gram potassium manganate 7, which is, as we know, an oxidizing agent, is needed for the complete oxidation of 23 grams of ethanol under acidic conditions. How many moles of ethanol can be completely oxidized by 1 mole of potassium manganate 7 under these conditions? Okay, so let's figure out what is the number of moles of KMnO4 at the moment. We know KMnO4 has an MR of 158 and ethanol has an MR of 46. So judging by that, number of moles of potassium manganate is 63 over 158, producing 23 over 46 moles, which is again number of moles of ethanol that's over here. Now, if I had 1 mole of this, how many would I produce? That's a pretty straightforward ratio method. If I do that, I'm going to get 1.25, which is my answer. All right, let's do section B. Okay. Now, reading this question, I have a solution, and in solutions, I can only use the mole ratio to figure out the volume or anything that I need. So I'm going to use the straightforward 3-step method that we have. Let's figure out the number of moles of the solution that we have. That is going to be N equal to CV. Now, of course, there's no marks for formula, but if you write the formula, it makes sure that you're on the right path, and it also allows the examiner to see what you're trying to achieve here. So 20 over 1000 is my volume that of the solution, and 0.15 is my mole per dm cube concentration. That gives me 3 into 10 per minus 3. It's perfectly fine to write it as decimals or in standard form, whatever you prefer. Now, judging by that, I know that 1 mole produces 1 mole of the volume, the nitrogen. So 3 into 10 per minus 3 will produce the same. That's going to be 3 into 10 per minus 3. Now, volume of 1 mole of any gas is 24. So I'm going to use that idea. So 3 into 10 per minus 3 times 24 will give me the volume of nitrogen I get, which comes out to be 0.072 dm cube. It's important to pay attention to the unit here. If they had given us cm cube, then we would have to convert it to cm cube by multiplying by 1000. Water and oxygen are formed when hydrogen peroxide decomposes. Alright, we have the equation here. That's pretty simple. Let's figure out the MR of H2O2 for this one, because we want to figure out, we have mass of hydrogen peroxide. Now that's going to be 2 times 1 for hydrogen plus 2 times 16 for oxygen, which is going to be 34. This 2 is not part of it because that is basically the mole ratio thing, that not relevant when it comes to calculating the MR. So what does it say? It says that 2 moles of this produces 1 mole of oxygen. So I'm using again the formula method. So what moles of hydrogen peroxide do we have? We have 16 mass divided by 34. That's going to be my MR, which is going to give me the number of moles. Now that's a number I can use straight away. I don't need to simplify this any further. Then this is going to be number of moles. Judging by the mole ratio, 2 moles of this thing produces 1 mole of oxygen. 16 over 34 will produce X. I cross multiply, I get X equal to 16 over 68. That is my moles of oxygen being produced. Now 1 mole of any gas is 24 dm cube at room temperature and pressure. This one's going to be 16 over 68, which my moles, multiply by 24, which is my volume for 1 mole. This is going to give me the overall mole volume, which comes out to be 5.65 grams. Now these are 3 significant figures, so I can just write it like that. Notice that I did not simplify any value throughout my process because I don't want to compromise on my actual value. So this is a method that you can use if you're comfortable with fractions. If you're not, I would suggest either convert it to decimal places or be more comfortable, practice a few questions for fractions in your maths class. Alright, moving on. We have question number 2 here. Again, the similar equation, but this time they're not asking us to calculate any value for volume or mass, or in fact they're asking us to calculate the heat energy release. Now these are questions that have not been coming for a lot, like they are pretty recent when it comes to being tested in the exam. So I would suggest that you do practice a few of these questions. Now it's pretty straightforward. Just remember that they're saying 1 mole of hydrogen peroxide produces 98 kilojoules of heat energy. So instead of having volume or mass, they're just converting it to heat energy. That's perfectly fine. Now they're saying 1 mole produces this. So what's the mass of 1 mole? That's going to be MR, which is coming out to be 34 grams. We just calculate the MR. So 34 grams is 1 mole. So 1 mole produces 98. That means 34 gram produces 98 kilojoules. Now I have 680 grams. How many does that produce? That comes out to be 1,360. If I don't prefer this method, what I can use is find moles of 680 grams. So 680 divided by 34 gives me the number of moles, which is going to be 20. So 20 moles of hydrogen peroxide. I multiply that by 98 to figure out how much kilojoules is this producing, and that comes out to be 1360 kilojoules again. Propyl ethanoate is prepared by reaction between ethanoic acid and propanol. Now, even if you haven't studied organic chemistry, don't worry about it, because the compounds and everything, their properties are not being tested here. You're being asked to use moles concept. So that's perfectly fine. Now, what are the 2 things that are important here? The acid part, which has this H at the end, identifying that it's acid. This OH tells me clearly that this is not acid, in this context at least. Now, this is the thing that's important. And they're basically telling us that you have excess propanol. So this thing is propanol. It's in excess. I don't need to worry about its amount. I have 7.2 grams of this other thing, which is ethanoic acid, and I'm producing this thing over here. Now, it's important to know that because I want to find the mass of this thing, I need to know the MR of that thing. And in fact, while we're at it, let's calculate the MR of ethanoic acid as well. So ethanoic acid, the MR is going to be, there's 2 carbons, so 2 times 12, plus 4 hydrogens, that's 4 times 1, plus 2 times 16 for oxygen, that gives me 60. Similarly, MR of the other thing, which is propyl ethanoate, that is going to be, how many carbons I have? 4, so 4 times 6, 12, plus I have 10 hydrogens, so 10 times 1 plus 2 times 16. So that is going to give me, in fact, I have 5 carbons, so I'm going to change this number to 5, so I have 5 carbons. So my total MR is going to be 102 grams. Now, how many moles of ethanoic acid do I have? 7.2 divided by 60. That is the number of moles of ethanoic acid, which is 0.12 moles. Now, this is the number of moles of ethanoic acid. Let's figure out how many moles of propyl ethanoate it produces. The mole ratio is 1 to 1, so it's also going to produce 0.12 moles. That's easy. I'll multiply it by MR of that thing. So that gives me 12.24, and that is my final answer. There's the mass I'm going to get. And that brings us to the end of this worksheet. I hope you understand it. Keep on practicing, and if there's any issue, feel free to post your answers or questions in comments. Thank you so much.